Today is January 19th and this is the medium daily integral for today. So please give it a try and now we'll start. So we have a very interesting integral here. So we have a cosine, then we have an arcsine, then we have an arccosine, then we have a sine. So it's very nested. So let's first try to remove this arccosine. Okay? First, let's see how we can represent sine of x. Sine of x is the same as cosine of pi over 2 minus x. Okay, this is a cofunction identity. We can also prove this. So let's quickly show how this is true. So we have cosine of a plus minus b is equal to cosine of a cosine of b minus plus sine a sine b. So this is just a sum and difference formula. So if we have cosine of pi over 2 minus x, this is the same as cosine of pi over 2, cosine of x, then since we have a minus, we need to turn that into a plus, sine pi over 2, sine x. So this is cosine of pi over 2 is 0, so this whole thing comes 0, plus sine x, sine of pi over 2 is 1, so we get sine x. So these two things are definitely equal. Okay. Now, let's see what happens if we plug this in. Well, pi over 2 minus 1, pi over 2 plus 1. We have cosine of sine inverse of cosine, of cosine inverse of cosine of pi over 2 minus x. I'm probably going to put a wrong amount of parentheses. Cosine inverse and cosine are going to cancel out. So we get the integral from pi over 2 minus 1 to pi over 2 plus 1 cosine of sine inverse of pi over 2 minus x. Okay, now we have something which we can't deduce easily. Sine inverse of pi over 2 minus x. We can't do that the same way like we did here. So what we're going to do is we're going to draw a triangle. Sine inverse of pi over 2 minus x, well, what does that mean? That means we took some angle, let's say theta right here. We went opposites and the hypotenuse, and we said the ratio at sine theta, right, the opposite of our hypotenuse was pi over 2 minus x over 1. So we can, at the simplest ratio, we can leave this like this, right? So we have sine inverse of pi over 2 minus x over 1 is theta, okay? Now, what's this value here going to be? Well, that is going to be, let's call this b for now. We have pi over 2 minus x squared. Okay, well, before we do this, just to simplify this out a little bit, let's let c equal pi over 2 minus x. So we now are going to have dt is equal to -1. Well, so that's negative dx, right? So we now have t, so we have a negative here. Pi over 2 minus 1, well, pi over 2 minus pi over 2 plus 1 is 1. Pi over 2 minus pi over 2 minus 1 is -1. Cosine sine inverse of t dt. So this is now the integral -1 to 1 cosine of sine inverse t dt. So again, we're going to draw a triangle, except this triangle is going to be much nicer now since we'll just have, let's call this theta, opposite is t, hypotenuse is 1. Now what this is going to come is square roots of 1 minus t squared, okay? Because we can just use the Pythagorean theorem, right? And we get this. Great. Okay, so now we want to find the cosine of this angle. So we know that sine of theta is equal to t. We want to now we took sine inverse of t is equal to theta. We want to now find the cosine of sine inverse of t, and this is the same as cosine of theta. What's cosine of theta? Well, that is the adjacent over the hypotenuse. So this is the same as the square roots of 1 minus t squared. Well, we now know the answer to here. So we now have the integral from negative 1 to 1, the square root of 1 minus t squared, dt. And we can notice that the bounds on this integral make sense. From negative 1 to 1, this square root is always positive. So now we can integrate this. So I guess you could do this in a couple of ways, right? One way I would say is at least a nice way to look at this is as a circle. Let's say we draw a circle like this. The square root of 1 minus t squared, well, let's say we have negative 1 here, 1 here. This is going to be a circle something like this, right? So this right here is square roots of 1 minus t squared equals y, right? And what's the radius of the circle? The radius of the circle is 1, right? So the radius of the circle is 1, so what's its area? Well, area is pi r squared. R is 1, so it's pi. And we want to find the area from negative 1 to 1. So that's the area of this semicircle. So that's the area of this semicircle is pi over 2. So the value of this integral is pi over 2.